Okay, so now let's do one more question in source transformation. Okay, here this is so in the source transformation circuit there is a dependent source. Okay, this is the dependent source, and the value of that dependent, this is a dependent voltage source. Okay, and the value of that voltage source is 10I, and what is I? I is the current through this 50 ohm resistor. Okay, so basically this is a current controlled voltage source, right? This is a dependent voltage source which is current controlled. So which means, so here the question is find the voltage at node 2. So that means this is the node 2, which means you need to find the voltage at this point. That is the question. Okay. So here one thing you need to understand is that if there is a dependent source in the circuit, then don't make any change to the controlling factor. See here in this case, this is a voltage, this is a dependent voltage source, and here the dependent voltage source, the value is 10I. Right, so 10I, so I is the controlling factor, so don't make any change. What is I? I is the current through this 50 ohm resistor, so that controlling factor should not have any change, which means you should not apply any source transformation to the 50 ohm resistor, because you need that current stay the same value current I flowing through that resistor. You need to protect that current. Okay, because if you change that current, then this will also change. That's why, right? So that's why, so which means don't make any changes in this resistor. Okay, you can apply source transformation any way you want except in this element I. Okay, that's the only thing regarding the dependent sources. So now you can apply source transformation anywhere. Okay, so which means here this is, what is this? This is a resistor in series with a voltage source, right? Even though this is dependent, you don't have to worry about whether it's dependent or not. You can simply assume this is a normal voltage source in series with a resistor. In that case, if I want to convert this voltage source with a series resistor into a current source with a parallel resistor, what should be the value of that current source? The current source is I is equal to V by R, right? And what is V? V is equal to 10I by R. R is 100 ohm, right? So this is basically I by 10 or 0.1 I. This is 0.1 I. That is the value of the current source, which means this dependent voltage source can now be changed into a, this dependent voltage source can now be changed into a dependent current source, right? No change over here. This is 15 volt. Okay, and this can now be drawn as a current source, a dependent current source, which is going up, and its value is 0.1 I. Okay, with a parallel resistor, this resistor 100 ohm, and then I will draw another resistor for this one, that is also 100 ohm. There you go. Okay, so like I said, do not touch this current I. That is one thing. The dependent source means do not touch the controlling factor, because you should not make any change into the value of I. That's why no change should come to the value of I. That's why. So now if I want, I can combine these two resistors, right? So on combining these two resistors, I will get 50 ohm, right? Half of it. Combining two same parallel resistor values, it will become half of that resistor value. Or if you know, or you just simply look at this. That is, this is nothing but 100 into 100 by 2 into 100, or 100 plus 100. So you will get 50 ohm. So which means this is basically, this can be simplified into a voltage source with a series resistor with a current source. Okay, 0.1 I with a current source, and these two resistors combined, and they will become a another resistor which is also 50 ohm. This is 50 ohm, and its value is I. This is 15 volt, right? 15 volt. There you have it. Okay, so now what I can do is that these two again I can change this back to a dependent voltage source, right? A voltage source with a series resistor, right? So applying source transformation over here, this will become, what is the value? This V is equal to I into R. What is the value of I? 0.1 I. 0.1 I into what is R? 50 ohm. 50 ohm. What is this equal to? This is equal to 5I, right? 5I volt. 5I volt, right? So basically this becomes a 15 volt with a series resistor, and these two will combine, and I can draw it like this, right? With a resistor, a series resistor with a series voltage source, which is equal to 5I. No, it's a diamond shape. It's a dependent source, right? So it should be diamond shape. Okay, plus minus, right? So what is the value? 5I. 5I. This resistor is same, 50 ohm, right? 50 ohm. And this is 15 volt. And this is 50 ohm, right? So now if I want, I can find the voltage at this point, right? The question was to find the voltage at node 2. Which is node 2? This is node 2, right? This is node 2, the same, this is node 2, and same, this is node 2, this is node 1, right? So no change over here. So this is it, right? So this is the circuit, right? Let me redraw the circuit again. Let me redraw the circuit again neatly. Okay, this is 5I. This is how much? 50 ohm. 50 ohm. This is also 50 ohm, and this value of the current is I, and this is 15 volt, right? 15 volt, right? So now let me apply Kirchhoff's voltage law and find the value of I, because the name of the current is I, right? I itself. So therefore the current is I into how many resistors? 50 plus 50, right? 50 plus 50, that is the voltage drop, and the voltage source is 15 volt over here, and it is, this current is flowing into the positive terminal, which means this positive terminal is opposite, this voltage is opposing the current I, which means this is minus 5I. This minus 5I. Or in other words, this is how much? 50 plus 50 is how much? 100, right? So this is 100I is equal to 15 minus 5I, or this is 105I is equal to 15, or I is equal to 15 by 105. 15 divided by 105, and you get is 1 by 7 amperes. 1 by 7 amperes, or this is also equal to 0.143 amperes. 0.143 amperes. That's the value of the current, right? But the question is to find the voltage at node 2. This is node 2, this is node 1, and this is node 2. So the question was to find the voltage across node 2. So what is the voltage across node 2? Voltage across node 2 is the voltage across the 50 ohm and the voltage source, right? Voltage across the 50 ohm and the voltage source. Or in other words, or I can say that this, let this node be V2, okay? Let this voltage at node 2 be V2. In that case, what is the equation? The equation will become, that is, the equation will now becomes 50I plus V2, right? 50I plus V2 is equal to 15, right? Because 50I is the voltage across this 50 ohm, and V2 is the voltage across node 2, right? So if so I need to find the value of V2. So what is V2? V2 is equal to 15 minus 50I, or in other words, 15 minus 50 into 0.143, which is equal to, let me see, 15 minus 50 into 0.143, and you get is 7.85 volt. So therefore voltage at node 2, voltage at node 2 is equal to 7.85 volt. Okay.